Section 4.5 deals with area of a circle. As we said, you can't calculate the area of a circle as easily as multiplying two numbers together. Not like a rectangle, all you have to do is multiply one side times the other. This one here is a shape that you can't fit the blocks in perfectly, centimeter blocks, so you can't measure it using blocks very easily because you'll have part of blocks showing. So there is a formula for calculating the area of a circle, and it's a very simple formula. All you need to know is the radius. So if you're given the radius, you can easily find the area of this circle, how many centimeters squared or how many, whatever the unit is, squared. You always know pi is going to be 3.14. That's what we use for our pi. And r squared just simply means you multiply the radius together twice. So if the radius is 5, then you multiply 5 times 5, and you do that first, and then you times that by 3.14, and you will get the actual area of that circle. So let's do an example. In this case, we're given the entire thing across, and it's not the radius, as we're shown here. We're actually shown the diameter. The radius is not shown, but we need to know the radius in order to do this. Well, if we're told the diameter is 12, remember the radius is half of that. So 12 divided by 2 equals 6 centimeters. So now let's put that into our formula. Remember, area equals pi r squared. So let's write out pi as 3.14. Done. And let's work out r times r, which is 6 times 6. Now, you can do this a few different ways. You could use a calculator to work this out, and it might actually be a little bit quicker if you're allowed to use a calculator. But I can multiply 6 times 6 together fairly easy. 6 times 6 is 36. And then I got to multiply that by 3.14. So let's multiply that together and see what we get. So 3.14 times 36, and the answer is 113.04, and since it is in centimeters and its area, it's going to be centimeters squared. There. Here's another one. We're given the radius fairly easy. Remember, the area of a circle is going to be pi r squared. So we know what pi is. We always know what pi is. And in this case, we've got to square the radius, which means it's 4 times 4. We know what 4 times 4 is. That'll give us 16. And we've got the pi right there. Now all we've got left to do is go 3.14 times 16. The answer is 50.24. And that would be in centimeters squared. All right, that ends the one on section 4.5. The only other possible one you might get when you're doing area is sometimes you might be given, say, in this formula, area equals pi r squared. The only thing you might ever be given would be area, and you're to find the radius, but that will come at a later time. Section 4.6, interpreting circle graphs. Here we got a pie chart. Okay, sometimes it's called a pie chart, but the proper term is circle graph. We've got it broken up according to percent. So in this one, we've got about 40% of the circle shaded in with purple. Okay? And we know it's probably pretty accurate because half of the circle, or 50%, would go right down to about there, and all that shaded in. So we're pretty close to that. So how I get to school? Let's look at the bus. We'll say it's 40%. The car is 25%. The bike is 25. And those that walk to school would be 10%. Now, a few things to notice from this graph is that if you were to add up all this percent, so 40 plus 25 plus 25 plus 10, it all had better add up to 100%, or the entire thing. Okay? So that's something that you got to keep in mind, because if I didn't tell you how many walked, you could always add this up and see how much more you need to get to 100. So 100, take away all these three things, and what's left over would be walking. All right, calculating numbers based on a circle graph. So if you're given a percentage right here of people that take a certain route to get to school, whether it be bus, car, bike, or walk, we're going to see how many people is that in actual numbers. So the first question is, what percent take the bus? So looking at this, the bus is purple, 40%. Now, as you did in a previous chapter, it says write that percent as a decimal. And remember, 40% just means 40 out of 100. Now, as a decimal, we've got to go to the hundredths place. So this is the tenths, this is the hundredths. So we should have 40 hundredths. So it should be 40, decimal 40. If it was 50 out of 100, it should be 0.50. If it was 96%, it would be 0.96. So it's pretty easy to change a percent to a decimal because it's already out of 100. So the question now says, if there are 100 students in the school, how many go on the bus? Well, we got to multiply the percent by the total population. So what was our percent? It was 40%. As a decimal, that is 0.40. And how many students? Well, we have 100. So decimal 4 times 100. So decimal 400, 0.40 times 100 equals 40 students. And there you go. So what if there's 150 students but the same percent population? Well, if it's still 40%, we write 40% like that, and we want to times it by 150 students. Oops, a few more students than I wanted. So 150 students. Work that out, and we'll find out how many. So it's 0.40 times 100, times 150, 0.40 times 150, and the answer is 60 students. Now, you know that if I were to say just as an estimate, I would say, well, 40% is close to 50%, and half of 150 is 75. So we know it's going to be less than 75 because this is slightly less than 50%, or half of the students. So if we get any more than 75, we know our answer is way off. And the last one, what if we have 900 students in the school? How many go on the bus? Well, we said the bus students were 40%, which written as a decimal is 0.40. We want to times it by the total number in the school, which is 900. And again, we'll use our trusty calculator. So 0.40 times 900. And the answer is 360 students. 360 students go on the bus. Now you might be asked to find the missing percent like I said before. Remember, it's all got to add up to 100, so let's add them up. 25 plus 10 plus 40. Well, let's see what that adds up to. 25, 35, and then plus 40 more is 75. So I've got 75 plus a certain amount more is going to give me 100. So how much do I need? About 25 will do it. So I go 100 take away 75, I'll be left with 25. So this here should be 25%. And just by looking at it, you can see that this is roughly 25% or 1/4 of my chart. About what percent of this is shaded? Well, if you look at the whole thing is 100, it looks like about half of 100 is shaded. So that would be 50%. Looking at this one, well, if we look at this much is 100 altogether, this much is 50, and this looks to be about half of 50. So half of 50 would be 25%. Okay? And if you wanted to get really technical, you could always take that 25%, draw another line roughly in half, and say, what's half of 25%? Well, half of 25 is 12.5%. And you can keep breaking it down smaller and smaller and get a pretty accurate measurement with your eye without even using a protractor. All right, couple of problems to try. It said, Mr. Edison spent his allowance of $200 on Christmas lights. Here's a circle graph showing what color he bought. So I bought 25% of my lights were blue, 45 were green, and 30 were red. How much did he spend on blue lights? Well, what's the percent of blue? 25. So we've got 25%. Let's change that to a decimal, which is 0.25, and times it by my total amount of money I spent. So times it by $200, and we will then know how much I spent. So 0.25 times 200, and the answer is $50 on blue lights. I can then calculate how much I spent on red lights the same way. The red lights were, oh my goodness, I didn't calculate. Yes, the red lights were 30%. So let's change that to a decimal so we can multiply it. 0.30 times, I spent 200 total, and let's see what we get. 0.30 times 200 equals $60 on red lights. And of course, now I've got my green lights is 45%. So 45% changed to a decimal is 0.45, times it by my total amount of lights, and I should have 0.45 times 200 is $90 on green lights. Now, if I add all these three back up, I should add up back to $200. But you could ask for another question about this. It could say, what percent did he spend on red and green together? Well, here's the red was 30%, and the green was 45%. Altogether, that equals 75% of my money was spent on these two colors together.